In this video, we're going to go through related rates of change regarding differentiation. Now, this essentially involves the chain rule. So let's go through this question. The radius of a spherical balloon is increasing at a rate of 0.2 meters per second. Find the rate of increase of the volume, and part B, the surface area of the balloon at the instant when the radius is 1.6 meters. So what we do essentially for a question like this is, well, we know from G to C what the formula is for the volume of a sphere. So let's start off by writing down the volume of a sphere, which is 4 over 3 pi r cubed. Now, what we're going to do is differentiate this. So dV by dr is going to be 4 over 3 times 3 times pi times the radius squared. So dV by dr is going to be 4 pi r squared. So what we're going to do is now use the chain rule. So dV by dr is essentially dV by dt, because rate means with respect to time. So the rate of change of the volume is dV by dt. Now to get dV by dr, we just times it by dt over dr. Now this will be equivalent to dV over dr. Now we can now say, well, we can go back to our question and say, well, the radius of the spherical balloon is increasing at the rate of 0.2 meters per second. Now this is what dr by dt is, the rate of change with respect to time of how the radius is changing. So we now know what dt by dr is. So dt by dr is the reciprocal of that, so that's going to be 1 over 0.2. So now that we've got that, now dV by dr is 4 pi r squared. Now we know that the radius is 1.6 meters, so we can say that dV by dr is 4 pi times 1.6, which is the radius, and we're going to square that value. Now I'm going to get my calculator out and work out what that value is. So it's 4 times pi. Don't forget your calculator must be in radians mode, because this is calculus. So 1.6 squared. Now that gives me 256 over 25 times pi. Just make sure my answer is correct. No silly mistakes. Yep. Now that means I'm going to substitute these values in here. 256 pi over 25 is going to be dV by dt times by dt by dr, which is 1 over 0.2. So dV by dt is 256 pi over 25 divided by 1 over 0.2. Get my calculator out. Do this divided by 1 over 0.2. And I'll get 6.43. So don't forget the units. This is the rate of change of the volume. So it's in meters cubed per second. Now part B says to find the rate of increase for the surface area of the balloon at the instant when the radius is 1.6 meters. So what we're going to do for part B is say the following. Well, let's start off with the surface area of a sphere, which we know is 4 pi r squared. So we're going to differentiate this to give me dA by dr, and that's going to give me 8 pi r. Now using the chain rule, that's going to give me dA by dr is dA by dt times dt over dr. Now notice that we've got dt by over dr from the previous part, which is 1 over 0.2. Now, so what I'm going to do here is use that in this part of the question. So I can find dA by dr by substituting 1.6 into this. So 8 pi times 1.6, I can get that from my calculator. So I can say 8 pi times 1.6, that gives me 64 pi over 5. So 64 pi over 5. So I know what dA by dr is. I know what dt by dr is. Now I'm in a position to work out dA by dt. So let's substitute these values in. So dA by dr is 64 pi over 5. We need to work out what dA by dt is. I know this from the previous part of the question. That's going to be 1 over 0.2. So dA by dt is 64 pi over 5 divided by 1 over 0.2. So I get my calculator out to do the answer, divided by 1 over 0.2. That gives me 8.04 meters squared per second. Okay, here's another question. You can pause the video, give it a go, and when you're done, I will go through my work solution. Okay, welcome back. This question says that the volume of an expanding sphere is increasing at the rate of 24 centimeter cubed per second. Find the rate of increase, A for the radius and B for the surface area when the radius of the sphere is 20 centimeters. So we're going to start off by writing down the volume for this question. So the volume of a sphere, so we know is 4 over 3 pi r cubed. We can differentiate this to give me dV by dr is 4 over 3 times 3 pi r squared. The 3's cancel, so I get 4 pi r squared. Let's substitute 20 in. So when r is 20, dV by dr is 4 pi times 20 squared. So let's type that in straight to our calculator. 4 pi times 20 squared. That gives me 1600 pi. So let's use the chain rule now. So dV by dr equals dV by dt times dt by dr. Now we know what dV by dr is. That's 1600 pi. Now they've told us that the volume of the expanding sphere is increasing at the rate of 24 centimeter cubed per second. That's the rate of the volume, so that's going to be dV by dt. So we could write 24 in there times by dt by dr. So now we can say 1600 pi divided by 24 is equal to dt over dr. So dt over dr, so you get our calculator out, divided by 24, which is 209.4. But we want to do dr by dt, so it's the reciprocal of that, so I'm going to do 1 divided by dt over dr. I can get that from my calculator. So just go to my calculator here, 1 divided by the answer, and that gives me the answer there. So I get 4.77 times 10 to the power minus 3. Centimeters per second. Now for part B, it says to find the rate of increase of the surface area when the radius of the sphere is 20 centimeters. So we're going to write down the area as we did before of the surface of. So what we're going to do is write down the surface area of a sphere, which is 4 pi r squared. Differentiate this to give me dA by dr is 8 pi r. We know that r is 20, so dA by dr is 8 pi times 20. That's 160 pi. So now we can use the chain rule and say dA by dr is dA by dt times dt by dr. Now we know that this is 160 pi. We want to work out dA by dt. We've got this from before, so we need to be careful though. We need to do the inverse of this, so it's 1600 pi over 24, and then we could divide these two to give me the answer that I need. So therefore dA by dt is 160 pi over 1600 pi over 24. Get my calculator out, type it straight in, 160 pi 1600 pi over 24. So I get 12 over 5 or 2.4. So 2.4. Now it's in centimeters, so it's going to be centimeters squared per second.